Convert the following polar points to rectangular coordinates. All right, well again, let's start by thinking about the relationships that we know that relate polar and rectangular coordinates. X is r cosine theta, y is r sine theta, tangent of theta is y over x, and all I've really done at this point is written down the definitions of sine, cosine, and tangent, just having multiplied both sides of those two by r, and then finally, x squared plus y squared is r squared. And that's how we define r, thinking about it as a distance away from the origin. And now I'm ready to convert my points. Though in this first one, if I just think about plotting that polar point, I think I can write down its rectangular coordinate without doing much, right? I know I'm 4 units away from the origin, so I'm somewhere on a circle of radius 4, but if I rotate it to the angle at 90 degrees, I'm just at this point right here. So if I think about that, the x-coordinate is 0 and the y-coordinate is 4, I'm just a point on the y-axis. And I could certainly use my relationships, but I think plotting that point is the most efficient way of finding its its rectangular coordinate. All right, for this one, I'm going to graph it, but this time I will use my relationships. So an angle of pi 6, and then 2 units away from the origin, so somewhere on the circle of radius 2. All right. X is r times cosine of that angle theta, and y is 2 times sine of that angle theta. All right, well let's see, the cosine of pi over 6 is the square root of 3 over 2. 2 times that is the square root of 3. The sine of pi over 6 is 1/2, so I have 2 times 1/2 is 1, and my rectangular coordinate is root 3, comma 1. And that makes sense for this one. I go over about 1.7 and up 1 whole unit, and I end up right there on that circle of radius 2. All right, I do like to plot these first, thinking about the polar coordinates. It helps me kind of check my answer. So 2 pi thirds right here. So I go out 3, but the minus 3 tells me to reflect through the pole. So I'm thinking about a circle that is 3 units away from the origin and ending up right there in quadrant number 4. Well, if I think about that, that lets me know what signs I should see for x and y. I should see a positive x and a negative y, but my relationships down here are going to take care of that for me. All right, so writing down the expressions for x and y, just thinking about the formulas. All right, so now I have minus 3 times the cosine of 2 pi thirds. Well, the cosine of 2 pi thirds is minus 1/2. And the sine of 2 pi thirds is root 3 over 2. So all I now need to do is think about how this works. So let's see, 3/2 and minus 3 root 3 over 2. And there's my nice happy rectangular coordinate.